I start off by just looking at, if you like, a jigsaw puzzle of knowledge, what's required for those working on the land. And there's so much knowledge in this room, you could probably tick the boxes and say, yes, look, I know about soil chemistry, I'm into pharmacology, I know that. But these are the sort of sciences, if you like, that we probably need to get to grip to if we think we're going to fully understand our system to enhance and improve our productivity. Fertiliser, soil amendments, we don't need expansive definitions here. Basically, we're adding something to our soil there, hopefully to supply nutrients and provide the growth of our forage systems or food crops, fibre crops, what we're growing. And they may be either inorganic or organic or a mixture of both. And then we have soil amendments. And calling them soil amendments almost degrades them a little bit when really they're incredibly important. Because whether it's the use of gypsum or whether it's the use of lime, it's not only just adjusting chemistry, but it's having quite a marked effect on physical properties of the soil. And in terms of that, it's also obviously enhancing, providing an ecosystem there that's suitable for the microbiology, which Paul talked about as well. So incredibly important soil conditions. So in terms of soil assessment, it's a jigsaw puzzle of knowledge that we need to acquire. And I've been through that. The normal sort of chemistry stuff up the top there, as you can see with soil analysis, we get that done. Some people will get pediolar tissue analysis done. Then there's the thing that we used our observations to give us information. Plant and crop quality, crop production, animal health issues, pest and disease. All of that is telling you a little bit about the chemistry down here, what's being transferred to plants. Air and water, how can we learn from air and water? It's not necessarily a part of every analysis, soil analysis you get done, but you can ask for bulk density, which gives you a little bit of an idea about maybe structure of the soil and pore space. We do digging in the soil, which many of us have done, to have a look at compaction. If I use a highly technical piece of equipment imported from overseas, it's actually a bit of fencing wire, just probing into the soil to get an idea of compaction. Now, it doesn't take too much skill to actually recognise when there's sufficient moisture in the soil, if there's compaction issues in your soil. Digging in it, putting water in the top part of the soil, see how quickly it infiltrates will tell you about the soil structure itself, and pore space, air and water. We come down to organic matter soil biology. Yes, we can test that. We can get analysis done in laboratories that cost you something like $200 to get a biological profile or more of that soil. We've been using simple little field tests called Solvisa in little jars, like a Vegemite jar, which you half fill with soil, moist soil. And it's a bit like a colorimetric pH test. You put a little tag in there and read it 24 hours later. And the idea is measuring carbon dioxide respiration from the soil microorganisms in that soil jar. It's only a quick field test, but it has been validated by the USDA. And it's quite a good check to see what your own observational strategies are like out in the field. So you get a little bit of an idea of what's going on with biology there. Soil colour, the darker the soil, the blacker the brown, will tell you that there's a bit more humus in the soil. If you're observing earthworms and other soil life, looking where plant roots are going and whether there's soil particles actually attached to them. That's all giving you a bit of an idea of, if you like, the population of microflora and fauna in the soil. And maybe legume nodules as well. Look at those and split them open. Are they a pink colour? Are they operating efficiently? How many are on the actual roots of the legumes that you can see? Or giving a little bit of an idea of what's happening in the soil. So, in terms of what we've now assessed, the constraints to production, whatever our agricultural enterprise might be, is it nutrient deficiencies? Is it low organic matter that's holding us back? Low biological activity, the two probably run together there. Are there compaction issues, as the diagram on the right might indicate? Is nutrient cycling taking place? Are we adding compost and it's still sitting there for 3 years and not decomposed? Why isn't it decomposing if I'm putting it into the soil? Weed burdens, basically it's telling you a little bit about the balance of your system. If we're out in the pasture system there, is that a plant succession thing that we've moved the soil balance has changed? We've actually got non-nutritional grasses now coming up rather than the highly bred ones, telling you a little bit about nutrient balance in your soil. Pest and disease issues and animal health issues are all obviously potential constraints to your system. Organic matter, what's in them? And Pauline made a very good point about that too. We need to understand what is in a lot of these products. Poultry manure, compost, whether it's farm produced or green waste, whether it's biosolids, Cannery waste, great mark, humic materials, very much an opportunistic thing. You might be up in the Golden Valley and there's all sorts of cannery waste and things like that, apple holm and things like that, which actually are available that you might be able to use. But you as the controller of your enterprise needs to understand, I want to know what's in that product. It's your right to know. So if you've got poultry manure, if you're getting compost, ask for analysis. If you're dealing with biosolids, certainly you'd like to know what's in those, because obviously there's risks of all sorts of organic chemicals and heavy metals, things like that. So you want to know what's actually in the product that you're utilising. Just an example, grape mark, which is a fantastic resource, but quite often is actually dumped by large wineries. And just to have a look at the analysis of grape mark is very similar to deep litter found manure in terms of the analysis. So why wouldn't you use that as a resource? The actual photo shows a grape mark dump like that. I'm not suggesting you're going to dump that out in the middle of the paddock. You utilise it and compost it maybe with prunings or bring in green waste. So if you've got a windrow composting system, to use that resource. But in terms of dollars spent, you're dumping a resource that could really be quite beneficial. Now I know there is an issue in terms of vineyards with the high potassium content. If you're actually farming in the Yarra Valley, there's places with particular clays, lithic clays, which are quite high potassium content. You've got to be a little bit wary of the amount of potassium that it contains in that. But just an illustration of a resource and how much we should be optimising what we've got in our properties. Let alone the fact that if you're exporting that grape mark from your property, you're also exporting a whole range of other nutrient elements as well. We should be reusing. How do I choose which organic inputs to be used? Well, based on assessment, first of all, we go back to that assortment and say, yes, I saw low in organic matter, so therefore I'm going to use this particular one. This is just some data from some recent trials across the Westernport Catchment. And we've got poultry manure, litter, and you see there's a bit of a range there. There's farm compost, green waste compost. There's a fair range there of product. So if you're looking for things, for instance, they're slightly higher in nitrogen. You can see the poultry manure is obviously higher in nitrogen than over the farm compost, or green waste, which again is lower in nitrogen than perhaps the farm compost. What I want to point out a little bit too, which is really critical, and Pauline touched on this, is the carbon-nitrogen ratio of what you're putting into the soil here. Excuse me. You can see with the manure, there's high nitrogen content of the poultry manure. So we go to compost, there's a little bit wider spread, and the green waste up to around 17.5 or more. I think we mentioned the fact that once it gets beyond about 20 carbon, 1 nitrogen, then we might be getting into problems in terms of tying up nitrogen in our soil. This graph probably illustrates it really well, and this comes back to incorporating green manures or compost into your soil and how it's going to react. So on our vertical axis, we've got plant available nitrogen, positive up here and down here negative, as against time. And we've got 3 organic inputs we're putting into the soil here. The first one is basically a medical legume, which has around about a carbon nitrogen of 20 to 1, pretty similar to grass clippings. At that point in time, we wouldn't have to worry. If we put a seedling or a crop in at that point, there's no deficiency in nitrogen. We have excess there, that's not going to be an issue. If we're looking at wheat stubble, for instance, at around about 20 to 31, it's a little bit high in carbon, not so much nitrogen. If that's incorporated into the soil, you can see there's a tie-up across here until microbes start breaking down, given time, and that means oxygen, and it needs moisture in the soil before that operates. And then we start having a release of nitrogen into our system, and crops aren't going to suffer. There's the other side of the coin, vine prunings. Around about 30 to 1 is going to drag a lot of nitrogen out of the soil. So if vineyards, for instance, went through a mulch and mower into row areas and incorporated it into the soil, then there might be a problem for quite a while until that breaks down. So understanding carbon-nitrogen ratio, whether it's compost or the poultry manures or litter you're putting into the system, is pretty important in understanding how to manage it. So detecting it, I mentioned before that we can pay over $200 for a biological profile. Simple little test that we actually are using at the moment, Solvita Soil Health Test, which is just giving us a little bit of an idea of what's going on. And I'm a great fan for a landowner using their own observations. I had my garden stake in my car and forgot to bring it out here. If you've got a garden stake and you see it ends up like a spear, that degraded part of the fence post or the degraded part of a garden stake is telling you the depth of biological activity in the soil. Simple observation to make. Simple little things. Soil scientists use calico paper and measure resistance and strength when they bury calico or a fabric into the soil. We can do it easily. We use little 50mm squares of filter paper or cellulose buried in an onion bag with a little date mark on it and buried in various plots. Then we measure the percentage degradation of that over a period of time. Simple observation, yes, it's not totally scientific, but it is telling you about the activity that's actually happening in your soil. So that's really important. And of course, digging in the soil and breaking it up and crumbling. If you've got a soil with good soil structure and it's crumbling, well then those crumbs and those aggregates are there because of the organisms in the soil secreting polysaccharides and gums and resins which are holding it together. Little one down the bottom there, smell as well, is telling you something about that. If you've got an off smell with the soil, then obviously oxygen's not getting down there. There's something not going right with the biology of your soil. So we can use our own powers of observation. To encourage them, you need organic matter, they need a food source. Crop rotations are fantastic. Minimum tillage where you can. It's obviously going to give you the right populations and not degrade them. pH, the chemistry is pretty important. Minimise synthetic fertilisers, pesticides and herbicides. We've got to operate, we've got to produce food and fibre, but we must be aware that there can be some damage done there. And the use of foliar applications, seaweed, fish and others that may assist. And a word of warning, which Pauline said as well, trial these things. You don't need to buy a 44-gallon drum at $5,000. Just try a small thing, put a strip out, test it and see if it works for you. If you think it works for you, well great, you can purchase a little bit more and say that's fantastic. Value your observations. Yes, we can pay money for a soil analysis, a biological profile, but I put plus there. I think your observations of whether it's monitoring your crop health, your animal health, just because you're not a scientist, the fact I place a huge emphasis on the ability of people that are on the land to make the judgment on how their pasture is growing, the pasture composition and species, their animal health are all really important observations. Use that, of course, as well with soil analyses, but do value your observations. And to finish off, sustainable soil management. That's what it's about, that's what we're trying to enhance our systems. Thank you.